Hello, everybody. My today talk is about reducing the corrosion of transportation infrastructure by innovative green ITI cells. So first, I give you an introduction about this topic. Then I will talk about agro-based corrosion anti-icers, which at first step, I will explain the innovative extracting process that we have developed in our lab. Then I will talk about the sugar beet leaves based corrosion inhibitor, and after that grape waste based corrosion inhibitor. Then concluding remarks, and finally ongoing research. In US, about 27 million tons of de-icing salt has been used per year for winter maintenance projects. So these de-icers are harmful to transportation equipment, infrastructure, and the environment. The annual cost due to these de-icers can be up to $5 billion per year. About 25 to 30% of these costs are preventable with corrosion mitigating strategies, such as using corrosion inhibitors. In this figure, which is from the paper we published recently, we have shown the impacts of roadway de-icers to the quality of water, surface water, and also groundwater, and aquatic species. Also, it has impact on the human health. So de-icers are mainly made of freezing point depressants, which can be sodium chloride, magnesium chloride, and calcium chloride. These chloride salts has been used for decades and will be used for winter maintenance operations in next decades, because they are cheap and very available. So what are agro-based corrosion inhibitors? They are usually made of agro-based material, waste of agro-based materials. They can enhance ice melting capacity of de-icers and reduce the corrosivity of de-icers, and also they can remain effective on the road for longer time than chemical de-icers. The point is the common process of extracting of these green chemicals from agro-based materials is composed of dissolving a dissolving process which use solvents such as alcohol, acid, and even in some cases base materials. So this process needs a filtration process which can be costly, and also we have a huge amount of waste material which can be harmful for the environment. In this research, we have developed a new processing method which includes a chemical and biochemical degradation. This process is zero waste, and so we don't have any waste that should be dumped in the environment. So the production process of all biochemical materials are more environmentally friendly. So let's see if these materials are environmentally friendly by itself or not. First, I show you the extracting process that we have used. We get agricultural waste, we dry them and mill them to powder. Also, we have, in some cases, we have just used the dry material. but our experience showed that milling can improve the performance of the process. Then we do chemical degradation process using urea and an alkaline solution at low temperatures. After that, at room temperature, we do biological degradation. We adjust the pH at 8.5, around 8.5, and using a safe bacteria for 3 weeks, we do the biochemical degradation process. First paper we published from our research was in 2017 in ASC Journal of Materials in Civil Engineering. In this research, we used sugar beet leaves based corrosion inhibitor and magnesium chloride as deicer. So our results show that the solution containing sugar beet extract has much more corrosion resistance after even 5 days of test. Also, if you see the surface of the steel coupons which has been washed after the experiment, you can see sample A, which is exposed to the deicer containing sugar beet extract, has much less rust spots. And also this figure shows that the green inhibitor which we have developed in our research doesn't have any chemical bond to the surface of the metal. It just has a physical bond to the surface of metal and can be easily washed. So in the next publication of our group, we published in 2019, we used the sugar beet extract, dandelion extract, and some non-toxic chemicals to produce sodium chloride based deicers. First, I show you the chemical composition of the dandelion extract and sugar beet extract. As you can see here, sugar beet extract has more compounds inside that, and especially phosphorus compounds, which can be very helpful in terms of corrosion inhibition properties. In the next step, we use the uniform design to reduce the number of experiments that we want to do. And we use this dandelion leaf extract, sugar beet leaf extract, sodium metasilicate, sodium formate, and 23% sodium chloride. We dissolve this mixture in water and perform different experiments, such as measuring the corrosion rate of the steel coupon exposed to these deicers for 24 hours. You can see here all of the samples have a lower corrosion rate compared to salt brine, which is a good sign. And I have not shown every graphs, just here in this table I give you the normalized properties of these deicers. In ice melting, we measured ice melting capacity at -4 Celsius at 20 minutes and 60 minutes using the standard test protocol. And also we measured the corrosion rate, we measured the freeze thaw mass loss, and we measured low temperature asphalt stiffness and the low temperature asphalt M value for the asphalt exposed to these deicers. And using prioritization process. We scored them. These mixtures, I have not explained this process here because it's time consuming. So according to this process, mix one, which only had sugar beet extract and other chemicals, got the highest score. And also after that we did COD and Biod test. This mixture showed acceptable numbers of COD and BOD, which showed that it is not harmful for the environment. In the next step, we use different fruit waste to see which one works best for the green deicers, and we published this research in 2019. This time we use less salt, 18.4, and among the different fruits that we tried, the Concord grape had the best results. So this time we used central composite design and glycerin, sodium formate, sodium metasilicate, to produce green deicers. So again, using a similar process, we prioritized these deicers. Among them, mix 10 and beet juice blend. This beet juice is different from beet juice extract that we use. It is a commercially available deicer with a high concentration of beet juice byproduct. So these two mixtures had the best scores. So we used the experimental results and design expert software to predict the best performer sample, that has better properties than beet juice blend and also less impact on the environment. So we came up with the best performer sample that showed the highest score in terms of ice melting capacity, corrosion rate, splitting, the impact on the splitting strength of the Portland cement mortar, and impact on asphalt binder stiffness, asphalt binder M value, and also in terms of friction coefficient. So, and in the next step, we examined the BOD, which is the biochemical oxygen demand. BOD 5 means after 5 days of experiment, and COD, which is chemical oxygen demand of this deicer. You can see compared to beet juice blend, which is commercially available and used by many DOTs, or deicer has much less biochemical oxygen demand, and also less COD, chemical oxygen demand, which here you can see also it has better performance. So we could get a green deicer which has better performance compared to sodium chloride deicer, and also commercial green deicers, and less impact on the environment. So we can conclude from our research that bio-based solutions derived from locally sourced fruit waste have promising performance in terms of corrosion inhibition and also deicer properties. These deicers don't make any chemical bond with the for instance, steel. So they can be easily washed. Uh, and also the production process of them is very environmentally friendly. And also the final product has lower chemical oxygen demand and biochemical oxygen demand compared to traditional green deicers. Our ongoing research is on developing statistical models for the fate and transport of developed green deicer in soil, and also the role of these deicers on protecting buried steel pipes from pitting corrosion. Thank you for your attention.